So let's practice our new formula. The area of a regular polygon is 1/2 AP. If you're going to be using that formula, and it of course has to be a regular polygon, get in the habit of immediately drawing an apothem and a radius, because that's going to help you find the information you need. So suppose on this one we were told the radius of this triangle is 4 meters, and we had to find the area. So radius is 4. The reason we draw this apothem and radius is it creates a right triangle. We know all sorts of things about right triangles. This is a regular triangle. What does each interior angle measure? Well, if we take the total of 180 and divide by 3, they're 60-degree angles. But in the last video, we said the radius bisects the angles. So this would be 30 degrees. So this is a 30, 60, 90. Aha! Most important thing of the year, special right triangles, Pythagorean theorem. On a 30, 60, 90, if the hypotenuse is 4, the short leg is 2. If the short leg is 2, the long leg is 2√3. In the previous video, we said the apothem bisects the side. So if this is 2√3, that means this is 2√3. So the whole bottom side is 4√3. And if that's 4√3, then I can get the perimeter. Multiply this by 3. The perimeter must be 12√3. And now I have everything I need to use my new formula. I've got my apothem, I've got my perimeter. So the area is 1/2 AP. So 1/2 times the apothem times the perimeter. I guess that comes out to be 12√3 meters squared. So there's the first one. Let's try another one. How about this regular polygon? Well, if it's regular and it's got 4 sides, that would be a square. Now, it'd be a little silly to use 1/2 AP on a square, particularly because we have an easier formula, side squared, purely for practice. Because there are times when this is really the only formula you can use, depending how many sides it has. So let's do one where we already know the answer. Suppose every side length was 8 in the square. We know the answer has to be 64. But if I want to use that formula just to practice it, I would draw an apothem, I would draw a radius, got to fill in my angles. So now I got to think, what do the angles measure on a regular 4-sided polygon? Well, they add up to 360, and 360 divided by 4 is 90. Of course they're 90, it's a square. But the radius is bisecting that angle, we proved in the last video. So this is a 45, 45, 90. Special right triangle. We know this is 8. We know the apothem bisects the bottom side. So that's a 4. So on a 45, 45, 90, if one leg is 4, the other leg is 4. Because it's isosceles. So there's the apothem. The perimeter of the square is 8 times 4, 32. So the area is 1/2 apothem perimeter. 1/2 times my apothem times my perimeter. 1/2 times 4 is 2. 2 times 32 is 64. Like we said, answer 64. Sort of a silly way to do that problem, but I'm just practicing this new formula with you. Draw the apothem, draw the radius. We're going to do 2 more. How about a regular hexagon if we're told the perimeter of this hexagon is 48, whatever the units are. If I'm going to use that new formula on my regular hexagon, I start by adding an apothem and a radius. And you got to think, what are these angles? Every time the angles are going to be different. So we have a formula for the sum of the interior angles, n minus 2 times 180, number of sides minus 2 times 180, chapter 6. This comes out to be 1,080 degrees in a hexagon. But this is a regular hexagon, so I can divide by 6, and I can figure out that every angle in this hexagon is 120 degrees. But the radius is bisecting the angle. So instead of 120, this angle is exactly half, 60. Look at that, another special right triangle. But compare this one to the first one. Notice the 30 and 60 are in different positions. Got to be careful. You have to think about what does the angle measure on the interior angle on the original regular polygon. And this is how you figure that out. All right, so perimeter 48, I can divide by 6 and figure out that every side length here is 8. Every side is 8. That's a sideways 8 from how you're looking at it. Sorry about that. The apothem bisects the side. So that means this is 4, this is 4. All right. And if that's 4 on my 30, 60, 90, what's the apothem going to be? Which is the long leg. Most important topic of the year. Starting to see why I keep saying that. If you don't know your special right triangles, you can't do these problems. It would be 4 root 3. So there's the apothem, there's the perimeter. Area equals 1/2 times my apothem times my perimeter. So 1/2 times 4 is 2. 2 times 48 is 96. 96 times root 3 is 96 root 3. If it said to round it off, I would put it in my calculator, or I'd probably just type this into my calculator. But if I want the exact answer, there it is, 96 root 3. Last one, which is how we actually started this lesson today. I think it was on the previous video. What's the area of this regular octagon? Radius of 13. So I add my radius, and I add my apothem to create a right triangle. So I got to think about my angles. Might want to pause the video, challenge yourself. Can you figure out what every interior angle is on a regular octagon? I'll wait for you. So if you did 8 minus 2 times 180 and divided that answer by 8, you would get 135 degrees for each angle. But the radius bisects that angle. So this is 67.5 degrees, which means this angle is 22.5 degrees. Yuck! Not a special right triangle. Nothing special about that. So this is going to be a little more work. We need this apothem. I'll call it A for apothem. And we need to know the bottom of this right triangle. I'm going to call it X. Because if we could figure out what X is, we could double it to get the bottom of the octagon. Remember, the apothem bisects the side. So if X is 2, this would be 4. And if we can get the side, then we'll multiply by 8 to get the perimeter, and then we can use our new formula. So how do we get A and how do we get X if it's not a special right triangle? Everybody yelling at their devices? Trigonometry. SOHCAHTOA. Let's start with A, the apothem. If I want to get the apothem, I need to choose one of the acute angles. I like when a variable is on a leg, I like the angle across from it, but either one of these angles will work. So I'm going to use this angle. I recognize that I want the opposite leg, and I know the hypotenuse. Sine is opposite over hypotenuse. So the sine of 67.5 degrees is opposite over hypotenuse. The apothem is the opposite from that angle. This is the hypotenuse. So if I multiply both sides by 13, I get the exact answer for the apothem. And I'm not going to type that in my calculator. Yes, it says round off, but that's just the final answer we're rounding off. So I'm just going to set this aside for now. And now I'm going to work on finding x. And I'll try to write more upright. I may have to turn the paper and turn it back. So to get x, I look for an acute angle. I'm going to use the one across from it. And once again, if I'm wanting the opposite leg from the angle I've chosen and I know the hypotenuse, I'm going to write a sine equation in this case. So the sine of 22.5 degrees is x over 13. And I'm going to multiply both sides by 13. So x is 13 times the sine of 22.5 degrees. So that's what x equals. But if that's what x equals, what did we say we have to do to this number to get one side length? Remember we said if x is 2, this would be 4, and we have to double this. So one side of the octagon, if I double that, is 26 sine of 22.5 degrees. And if that's a side length, what did we say we do to that to get the perimeter? Well, since there are 8 congruent sides, we're going to multiply that by 8. And that gets me a perimeter of 208 times the sine of 22.5 degrees. Not rounding off my perimeter. So I have my apothem. And I have my perimeter. That's all I need to do my formula, half AP. So here it comes. Area is 1/2 times this apothem times this perimeter. 208 sine of 22.5 degrees. So when I type that in my calculator, first thing I'm going to do is I'm going to check to make sure I'm in degree mode. You don't want to do all this work and get the wrong answer because you're in radian, so I make sure I'm in degree mode. Quick way you can check that is to make sure the sine of 30 is you're getting 0.5 or 1/2. That means you're in degree mode. So I'm going to type in the answer that I have on my paper in front of me, 1/2 times 13 times the sine of 67.5, close the parentheses, times 208 times the sine of 22.5 degrees, close the parentheses. So the directions say round off to the nearest hundredths, that's 2 decimal places. So 478.00 in this case, 478.00 centimeters squared. There it is. That was a lot of work. This is going to be one of those videos where I recommend you go back and watch the 4 examples again, so when you try the homework you'll be very comfortable with what you need to do. Always draw the apothem, always draw the radius, and then you've got to figure out what the angles are inside that triangle. They're going to be different every time depending how many sides are on the polygon. Have fun!